Hello, boys and girls, ladies and gentlemen. This is Mr. Meyer coming from the South Side Way Happy Studios here in Livermore, and we're going to talk about variation functions. So, in math, there's a lot of things that can be modeled by a line of best fit. Well, direct variation is one of those. It's a line that goes through the origin, so the y-intercept is 0. So, if you look at that equation on the screen, you see the constant variation k. Kind of think of that as like the slope of the line. So here's our direct variation. It is the equation y equals kx, so that's our equation. And you have a constant of variation, k, and a lot of people will solve for k. In fact, that's usually what you want to do. And you will look for this constant ratio in direct variations of k equals y over x. That's important to remember later on in this lesson. But for now, you have to remember two things, really. That if you hear the words direct variation, you will use that equation, number one. And number two, that you usually want to solve for k, because k is actually a number. It's constant, and it's different in different problems, just like slopes are different in different lines. So let's go ahead and do an example. So looking at example 1, we are going to find out what's going on here. So as you see the equation, it says given that y varies directly as x, and y is 27 when x is 6, can you write that direct variation? So the way I do this is usually what will happen is I'll see the word variation or varies, and that's a key trigger to me. What I do is I always look at what letter's in front, or what variable or what word. Sometimes they will give you a word like bananas vary directly with something. And so you want to write down whatever that is. So I see the y, so I'm going to say y, and then varies means equals k. Now directly means you're going to multiply with whatever they say next. So if they say multiply directly with monkeys, you're going to put monkeys next. If they're going to say, in this case, as x, you're just going to put a little x. And that's your equation. Y varies directly as x. Done. They might say x squared. They might say the square root of x. Who knows? But you will be done at that point. Now, this is kind of your step 1 equation. It's not quite your answer yet. Now they'll give you some info, some data, something off a chart, off a graph, who knows. And you will plug that in because your job is really to find out what the heck is k. What is the constant of variation for this problem? So I know that y is 27 when x is 6. And so I can go ahead and put that in there like that. And I can solve for k now. And I'll get k equals 27 over 6. Hey, I think that reduces down. What is that? 9 over 2. And so there's my k value, or our constant of variation. Now that means we have an equation. We have an equation, y equals kx, or y equals 9 over 2x. That's the equation that models this situation. And that's our answer for the equation. So whatever you want to do, you want to find k, and then you want to plug it in, and that's going to be your answer or your equation. Then they might ask you a new question now. They might say like, hey, what's y when x is 3 or something. You never know. They could throw something at you, and you could solve it. In this one, they say write and graph the direct variation. So we got the writing of it. Now the graphing of it, kind of simple. Remember, these are just lines, and they're going to go through the origin. So if here's your x and here's your y, I'm going to start off at the point 0, 0. Our y-intercept is 0, and our slope is up 9 over 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and over 2. And there's my dot, and I'm going to connect those two bad boys, and there is my graph of my direct variation. And that's example 1. All right, let's move on.
All right, now let's do a real life Kids Bop example, right? I love Kids Bop. They're one of my favorite artists, and I just have to admit that I just got Kids Bop 27. And so after downloading the first 3 songs of the Kids Bop album, it took me 5 minutes. So how long is it going to take to download all 23 so then I can sit back, relax, and enjoy the music? So let's set it up. Notice that time to download is a direct variation to the number of tracks. So the time it will take is a variation, so equals k. Now it's directly, so that means multiplied by the number of tracks you're going to download. And so maybe I have 2 t's here, so maybe I'll call this the number of tracks, so then we can use a different variable. So I will have the time it takes is equal to k times the number of tracks. So now I can plug it in. I know that it took me 5 minutes to download 3 tracks, the number of 3 tracks. So my k value, my constant of variation, is going to be 5/3. But that's the constant of variation. That's how long it takes. That's my internet speed, really. That's how long it takes to download a song, or in fact, 3 songs. So now if I make my equation, it would be the time it would take would be 5/3 times the number of tracks. And so now that I know the number of tracks is 23, if you look at the Kids Bob album, you'll see 23. You will just grab a calculator then, and you will type this in and see what you get. So it looks to me like I have 5 times 23 divided by 3. It's going to take me about 38.3 minutes before I can start enjoying the beautiful music of Kids Bop. 27. Hopefully we can listen to it in class.
All right, one more for you before I'm going to maybe ask you a question or two. How do you solve these problems? Now, this is a great one. If you travel overseas and you got to convert your money from dollars to euros or the other way around, you need an equation. So we might notice at the airport that something costs $5, and then when we're at the airport in Europe, it's $3.85 euros. And so all of a sudden you don't want to know what the conversion is, right? So we know that euros vary directly. So E varies directly. So varies equals K. Directly means multiply. And the cost of the item in dollars. So multiplied by dollars. So there it is. There's my generic formula. Equals KD. Now I'm going to plug this stuff in. I know that the euros we said was $3.85 at the airport. And I know K is my constant of variation. D is my dollar amount. And now I'm just going to solve for K. So if I divide that over, I get 3.85 over 5. That's my constant. But that's, again, not my equation. My actual equation that people are interested in is euros is equal to 3.85 over $5. And now I can answer any questions. I can clean that up with a calculator. I can grab my calculator, divide that. I can make it a fraction and reduce it or whatever I need to do. It doesn't matter. So that would be my equation. But now what I want to know is if you're going to pay 10 euros, how many dollars did that cost you? So I'll just plug it in. I know that the euros is 10. I got 3.85 over 5 times the number of dollars. So I will multiply that 5 over and get 50 equals $3.85. And then I will divide by 3.85. And I can tell you exactly how many dollars it would be. So I will pull up a calculator and I will do 50 divided by 3.85 and I get $12.98. Well, they're going to round it up, $12.99. So the dollar amount is going to be $12.99 for that purchase. And you can kind of go back and make sense. Dollars were higher than euros over there, so they better be higher than the euros. Yeah, they are. Seems like a good answer. And there's a direct variation. Now, let me give you a break. Let me ask you a question about direct variations, and then we'll come back and continue this some more. Nice work on that problem. I can see you are really dialed in, so let's keep going. How about a joint variation? All right, so we got direct variation out of the way. Now, joint variation comes in. It just means that there's more than one thing. It means they're still multiplied together, so you just got to watch out, right? So for me, right here, you can see that my Sharks experience. I'm a big Sharks fan, and when I go to the Sharks game, my expense varies jointly with the number of sodas I buy and the number of hot dogs that I eat. There are two things there. Well, again, if you're just going to make an equation for that, maybe my expenses, so I will say my expenses vary. So there's that K, that whenever you see that word varies, think, ooh, there's a K. And I got to figure out what K is. Jointly just means multiply. So multiply with the number of sodas and the number of dogs. So times the sodas times the dogs. And then I could tell you, how many I ate of each one, and you could figure out this cost and find out my expenses. So again, whenever you see a sentence, you're just going to break it down and make sure you get that K in there, and then figure out what that K is usually is going to be our job. All right, so here's example 3. The volume of a cone varies jointly as the area of the base and the height. And so there's an equation right there just screaming at me, and you may even remember the equation from previous math classes, but let's see if we can get it now. The volume, so we'll say V, now varies, there's that equals K. Jointly means multiply. The area of the base, so let's call that big B, and the height, little h. And so all multiplied together, And there's kind of my generic equation, but this is not the one I would ever ask you for. This is the one that usually you are just setting up. The one I would ask you for is the one that has the actual K value figured out. So let's go ahead and do that. We know that V is 12 pi, and it's in cubic feet. So I'm going to go ahead and put that 12 pi in for volume. I have my constant, which is what I'm trying to figure out. The base looks like it is 9 pi. And the height looks like it is 4 feet. And so now you just go ahead and you solve this for K. So I got 12 pi equals 36 pi times K. And then I'm going to divide that 36 pi over. So divide that by 36 pi. And good news, those pi's will cancel. And I get that K is 1/3. So now I have an equation. Volume is 1/3 the area of the base times the height. Right? So that's how some of these equations were found, right? People had figured out the volume, they had figured out the area of the base, they figured out the height, and they wondered if there was a relationship there, and this is what they did. They found that relationship. So now I can use it to answer the next question. Can you tell me the area of the base if I tell you the volume and the height? Maybe for some reason we need to know what area the base is. So I would use the same equation. Volume equals 1/3 base times height. I will plug in the volume is 24 pi, and that is in cubic feet. And I have 1/3. I don't know the big B, but I do know that the height is 9. And now it's just algebra. 9 times 1/3 is 3, so I got 24 pi equals 3b. I will divide by 3, and lo and behold, I will have 8 pi is the area of the base. Now we got to be a little careful. This is all in feet, so let's make sure that we call that the area should always be in feet squared. So I will say that the area of the base is 8 pi feet squared, and I will have that completed. Beautificent, right? That's what we were looking for in example 3. Let's keep moving. There's another type of variation. It's called inverse variation. So you got direct variation, means multiply. You got joint variation, which means multiply more than one thing. And then you have this one called inverse variation. This guy's super popular. And inverse variation means divide. So notice that's still got that y equals k part, but we're going to divide by x this time instead of multiply. And if you're solving for k, you just multiply x to the other side, and there you go. It's a constant product that's always showing up in this problem. A little off to the side here, in pre-calc, I usually will write this as y equals k x to the -1. Remember your properties of exponents. Negative exponents mean move me to the bottom. So if you see me do something weird like that, I don't want you to freak out. It's just that I sometimes write it with negative exponents, and sometimes I write it as a fraction. I will try to write it as fractions, but again, you know what negative exponents mean, so don't panic. So let's talk about how we're going to do this problem. So again, if you start reading a math problem that has the word varies in it, then you got to be like, all right, y varies, that means y equals k. All right, same as before, and same as in joint, same as in direct, same as in inverse. But then when I see the word inversely, that means divided by now. So we're going to divide by whatever comes next. And this time we're going to divide by x. And so there's my generic setup. Now give me some info, some data. Let me pull it off a chart. Let me pull it off a graph somewhere that I can get those numbers. I can plug them in. I can tell you what k is, so this formula actually means something. And so I know that it's 4 when x is 5. I'm going to multiply that 5 over. I'm going to get 20 as k, and that's going to give me the actual equation that matters. It is y equals 20 over x. That is the equation that matters. Now, how do you graph that? Well, that one's a little crazy, right? If you've ever seen inverse variations or inverse relationships, or the book will probably call this reciprocal functions, they usually have a set of asymptotes, and I'll let you know they have what's called a vertical asymptote at 0, because you can't let x be a 0, because that would be bad. And this fraction, 20 over x, will never equal 0, so it will never actually be here. But this is called the end behavior asymptote. That's where the graph is headed. And so what happens is these graphs love to live on their end behavior asymptote, and they're going to either freak out up or down. We got to figure out which one. Then they'll come back from that, and they'll get back on that asymptote, or get really close to it anyway. So this graph's going to look kind of funky. It's called a hyperbola sometimes, and you'll see it if you've seen those before. You'll recognize it. Now, how do you graph anything? you then just plug in some points. So I can just try to think of, X's and Y's that work. You'd probably think of ones that you like when X is 1, Y is 20, so that's way up here. When X is 2, Y is 10. When X is 4, Y is going to be 5. And so you can start to see what happens is this little curve that goes like this. And boom, there it is. Ooh, what about negatives? What if we throw in some negative X's, like X is -1? Well, then Y is going to be -20. And, same thing. If X is -2, then Y is -10. And we get this craziness of X is -20, we're going to get Y is -1. And so here's what this graph looks like. It wants to be really close to that horizontal asymptote. And then it's going to kind of curve away from it because it's going to freak out at the vertical asymptote. The vertical asymptote makes it panic because it can't touch it. It can touch the horizontal, but it can't touch the vertical, so it's going to freak out and it's going to try to go around it, and it doesn't do a very good job. And then it'll come back from that, and it'll get back on the graph. We're going to learn more about those graphs later, but just for now, what you know is that you get to see what kind of weird graph it is. And that's an inverse variation. So you now have direct, you have joint, which means multiply both of them, and you have inverse, which means divide. So you're setting up your equations now on how we're going to go. So here's one that we can talk about. Example 5 says, the time needed to complete a race varies inversely with the runner's average speed. Bam! I just saw an equation, right? You tell me that the time varies inversely. So I'm like, sweet, I got time equals K divided by something because you said inversely. And it's, the average speed S. So I can plug in some numbers. It looks like if the runner has an average speed of 8.82, that the time will take him is 2.97 hours. And so now I can multiply and I can figure out what our K value is. So again, I'm going to pull up my calculator and I'm going to say 2.97 times 8.82, and that's going to give me 26.1954. 26.1954 is our K value. So the time it takes is 26.1954 over the time. Or the speed, I'm sorry. And there is my equation. And that's our equation for this race. And now if you tell me a runner who ran the race, he averaged 3.5 hours is how long it took him, I could tell you what his average speed was for that entire race. So I put in 3.5 hours for his time, and I have this little constant right here, which seems to be a marathon, divided by seconds. I'm going to multiply this out, right? So I'm going to multiply S to both sides real quick, and then I'm going to divide by that 3.5, and I get 26.1954 divided by that 3.15. I'm going to grab my calculator, and I'm going to say divided by 3.5, and it is going to tell me that that person's average speed was 7.48 miles per hour. So their speed, 7.48, I think it's 44 miles per hour is what their average speed was for their time. And so I now know how fast they were going. So why don't you try some inverse, and we'll see you after the break. All right, nice work again. Now, let's wrap this up. So we're going to talk here about what if they don't tell you what type of variation it is, and you're just looking at data. So see down here in example 6, I'm just looking at data going, I don't know if it's direct or inverse. Well, we know some important information. We know that direct variations all have that multiplying thing. So they have the form y equals kx. And they should have the same k for every problem. So if it's all that you care about is the k, as you do in this case, you would just do y over x to see if you get the same number every time. Now that's a little confusing, right? Because it's a direct variation. And look, when you talk about the k value, you're dividing. Well, guess what happens on inverse variation? You know your formula is y equals k over x. And if I just want to know what k is, I would multiply the x to both sides. So I get xy equals k. And that is my inverse variation check. So if I just have a bunch of data, right? Just a bunch of data. We did a lab and we have all this data and we want to know Is a direct variation or inverse variation better to check with? The way you check is you look at your data and you divide the y over x's and see if you get the same number every time. Or you multiply the two together and see if you get the same number every time. If you do, then you're going to pick that variation, and if you don't, you're going to say, hey, it's neither of these. So now I'll just grab my calculator, and I will look. I'm going to do all the y's over the x's for the first one to see if it's a direct variation. So 8 over 6.5. I better be a little more careful. 6.5 is 1.2. Then 4 over 13, right? And that is 0.3. Okay, so pretty good giveaway right there. I'm going to double check my numbers. Oh, yeah, I typed them all in. So that's not a direct variation. So A is not a direct variation. So let's see if they multiply together, and then it'll be an inverse variation. So 6.5 times the 8, and I get 52. 13, hey, I played cards. I know 13 times 4 is 52. What about half of 104? Also 52. So I can tell you that this one right now is an inverse variation because as I did my check, right, as I checked each time, the x and the y multiplied together always came out to 52. So you could even say like k is 52, so you save yourself some work. So we got that one. Let's try B. I'm going to do the exact same thing I just did. In fact, looking at it, you might be pretty comfortable. First, we're going to divide, right? So 30 divided by 5 is 6. 48 divided by 8 is 6. 72 divided by 12 is 6. What? So I already know that that's a direct variation. And I am feeling pretty good about that because I'm finished. And it looks like K is 6. And I got my answer. Now I'll do the same thing for the C. I am going to divide. I get 5/3, and then I get 14/6, which if I simplify 14/6, that's what, 7 over 3? So 5 over 3 is not the same thing as 7 over 3. So direct variation is a no-go. So let's just multiply them together. Here I multiply, I get 15, but over here I get, what, 60 and 24? So it's like 84. So 15 and 84 are not the same. So this is neither direct or inverse. So I will say neither, and I have now completed. And one last example, but this is running a little long, so I think you're good. I'll just set it up for you for a quick second, and then maybe you can try it out and let me know what you got for it. It just tells me that the change in temperature of an aluminum wire varies inversely. Ooh, so all of a sudden I'm like, oh, I'm paying attention, right? So the change in temperature, so maybe change in temperature, right, is like how we like to write it, varies inversely, so equals K over whatever they're going to tell me, the mass, so M for the mass. Ooh, and directly, so that means now multiply that. You don't have to put another K because you got your K, and directly with the amount of heat energy, so E, that is transferred. So there is my setup for this problem. Now I can plug in a bunch of things that they want. I can figure out what K is, and then I can probably answer the question. But I'll leave that for you to do. You have a great night. I'll see you tomorrow in class, and stay happy.